that a little bit later, but I like to do naming earlier so that we can use those principles throughout the rest of the year. So we will get to talking about what makes up an ionic compound and how is it formed and how is it bonded and things like that. And we'll get to covalent and all that stuff, but I want to learn how to name them first. So ionic compounds are between a metal and a non-metal. You agree? Agreed. So a covalent compound is this time between two non-metals. Okay, and so where are non-metals located on the periodic table? Where are they located at? Right. On the right-hand side. So there's not very many non-metals, right? It's a much smaller section of the periodic table than metals. But covalent naming is between two non-metals. Now, what are the charges on all non-metals? Negative. So is there any way, if I put together a negative and a negative, would it ever come out to be a neutral compound? No. So here's the thing about covalent naming is that charges do not matter. I think that covalent naming is the easiest type of naming that we do because it is very, very straightforward. Okay, you name things exactly as you see. There's no crisscross. There's no balancing of charges. It's just you see it and you name it. Okay? So, how many of you have your textbooks with you? Not so many. All right, good job, Zeno. There's a table in the textbook, and I'll just put it up here on the board. But it has prefixes that we need to use to help us with covalent naming. And so those prefixes are things like mono, di, tri, tetra, all that kind of stuff. So I'm going to put that table up on the board for you to be able to see. And then I want you to copy that table down into your notes. Okay. 1, 2, 3.
How long have you been using?
Well, it's got prefixes and the numerical value that goes with it. So I would like for you to have that table in your notes. A lot of them are familiar to you, but there are a couple that are new. Tetra, I think, is one that's different. For 4, we usually think of what prefix? Quad, right? That's usually the prefix that we think of, but for chemistry, we use tetra. So other than that, they're pretty straightforward. So go ahead and get that table down into your notes, please. You might know that are covalent compounds. What would I call that compound right there? What do you know that the name of that is? Carbon dioxide. Okay. Now, this is just a common one that we just happen to know the name of. What about this one? CO. What do we call that one? Carbon monoxide. Do you see the difference? Mm-hmm. Right? What's the difference there? O2 is dioxide. O1, right, is... Oh, I didn't put it in. Sorry. Moxide. Sorry. Oh, goodness. Okay. How about that? Monoxide.
It's a Thursday.
Yeah, that's right. Thursday at 12. Everyone's most tired time. You see the difference, right? There's a couple rules that we're going to go through to kind of set up ourselves for covalent naming, but I want you to see the patterns. It ends in IDE, just like our previous ones did, right? Just like ionic compounds do, they ended in IDE. The first one gets to keep its regular name. All that type of stuff are all rules that go with covalent naming. Okay, so I'm going to give you kind of a list of the rules we're going to follow, and then we'll do some more examples, okay? So rule number one. Rule number one is that the element... If you're making a compound, the element farthest to the left on the periodic table goes first. Okay, so if you're just having to build a compound without really other knowledge, it's always that the element farthest to the left goes first. So if you have a compound between phosphorus and bromide, you would put PBr. Right? Or P2Br2 or whatever the ratio is, but it's going to always work left to right on the periodic table. And that same thing is true for ionic compounds as well. But in covalent compounds, the element that's farthest to the left is going to be listed first. Okay? Naming wise, the first element only gets a prefix if there is more than one. Okay, and so what that means is that we didn't call this compound monocarbon dioxide, right? Do you see that? I didn't call it monocarbon dioxide. It's just called carbon dioxide. If I have more than one of that first one, okay, let's say that my compound was this, C2O2, this would be called dicarbon dioxide, right? So the first element only gets a prefix if there is more than one of it.
Why do we call water water?
Yeah, that just has a special nickname, right? Rather than dihydrogen monoxide, right? Some people call it that. That's its official name, but water just is so specific. It gets a nickname, I guess. But yeah, that's a good observation. Okay, let's see here. All right, next rule. The first element keeps its regular ending. So it's not going to have an IDE ending. Okay, the first element keeps its regular true ending.
What if you had like neon and argon? Which one would go first?
Okay, yep, you would work bottom to top. So argon first, then neon. So the rule with that is really the rule stems from whatever is farthest away from fluorine, the element fluorine, that's the element that goes first. So the element that's farthest away from fluorine really goes first. And that has a lot to do with what's called electronegativity and stuff we'll get into later. But essentially the rule is, left to right or bottom to top. Good question. Okay. The second element in your compound always gets a prefix. So the second element always gets a prefix. Okay? And it ends in IDE. Okay, so those are kind of our sets of rules for naming with covalent compounds. The first element keeps its true elemental ending. The second one ends in IDE. The first one only gets a prefix if there's more than one. And the second one gets a prefix always.
What is it? Freshman?
It's freshman.
You go tell them. Let's tell them.
What could have made that noise?
Okay. The last rule I'm going to give you is more of just a spelling and pronunciation type rule. It's really not the end of the world, but it's kind of a suggested thing. So the last one I'm going to give you is that you drop the O or the A from the prefix if the element starts with a vowel. Okay, you drop the O or the A from the prefix if the element starts with a vowel. So let me give you an example. If you had one that said O4, right? If it was, let's just do a full CO4. We would call this carbon, right? Not monocarbon, but carbon. And then what's the prefix for 4? Tetra. So rather than say tetra oxide, right? The rule says to drop the A from the prefix. And so it would be tetroxide. Okay, so carbon tetroxide. We drop the A out of the prefix because our element started with a vowel. Okay, and it's really just a speech and pronunciation type rule, but
What about for like try and die?
nope, the I gets to stay. So even if you have I3, it would be called triiodide. I know, I don't make the rules. I just spread the rules, but I don't make them. So I don't really know why. Yeah, I don't know why the I necessarily stays, but it would be odd to say troxide, right? I think the I is part of the reminder of 3, but yeah. So you drop the O or the A. So that means that would apply to mono, tetra, penta, all the ones after that. So just not di and tri. Okay. All right, let's try a couple examples here. Give me the written formula for that compound. All right, did we have to do any crisscross here? We have to do any crisscross, no balancing of charges, no nothing, right? It's just very, very straightforward. What you see is what you get with covalent compounds. So this is a big O, I'm sorry. So SO3. So this would be sulfur, right? Keeps its regular ending, trioxide, right? Sulfur trioxide. No crisscross, nothing like that, right? And tell me, why is this one not sulfite? Right? Sulfite is SO3. Why is this not sulfite? Do you know the difference? It's neutral. It doesn't have a charge. That's right. It's neutral. Okay. So sulfite, if we were going to say it was sulfite, that would be SO3 with a -2 charge. And since this one does not have a charge listed, it's not sulfite. It's sulfur trioxide. Right? There's a difference. Okay. If I gave you dinitrogen tetroxide, what would be the chemical formula for that compound? Dinitrogen tetroxide. And 2O4, is that what we had? Right? Think these are simpler than ionic ones? Right? It's just read it and say it, right? It's not, no worrying about charges, no moving things around. They just stay. Okay? All right, I want you to do these 3 on your own, and then we're going to do a little partner work with them. Okay, we've got to make sure that we've got our regular endings on our first elements as well.